either R or L, like something like the.
But in Japanese, I know that it's not common, and people don't pronounce R
No.
like
no.
Lee only.
Right.
Mikinori.
Right.
All right, good afternoon. We may have a couple of minutes and then we will start the seminar today.
Huh? Yeah, I think this picture was taken by Jim. Like J Cube.
Right?
Right.
No longer.
Oh, Larry.
Oh yeah.
You another one.
Right. Yes.
Jurong East.
Right.
Really?
Mm.
You don't look at your ears.
Like
What did it do to you?
like right. Yes.
It's ever for me. It's ever ever.
Sorry, I just made some adjustments.
Yeah.
Oh,
Okay, good afternoon again. Welcome to the seminar today. I think we still have, some of you may still have a memory, painful one in 2015, when you come across that you find a lot of the air purifier in offices. And then during the tropical or the transatlantic haze issue in Singapore before. So today we are so glad that we have one of the experts in the world that are looking at the tropical peatland fire haze in Southeast Asia, Professor Kuwata from the Peking University. And he is currently the assistant professor in the Department of Atmospheric and Oceanic Sciences. And then he got his PhD in University of Tokyo and worked as a postdoc in Harvard. We have a little bit over the time. And then after postdoc, he worked as a assistant professor in our ASE here for 6 years, and then moved to the Peking University. And then today, as you can see in the title, that we are going to learn the situation or his latest findings of the tropical peatland fire haze in our region here. So please join me to welcome Professor Kuwata.
Okay. Thank you very much, everyone, for coming, and thank all Xiaofran and Steve for hosting my visit. And so, I guess as Steve introduced, I think for people who have been living in Singapore for more than a few years, everyone knows that how important the haze is. So I'm not going to talk about why the haze is important, but I'm trying to talk about when the haze started to happen and what we know about the haze and how haze has been impacting our life. So before going to the detailed talk, you may wonder what I have been doing in China after leaving Singapore. So after moving to China, I stopped working on atmospheric observations, because there's already so many people in China, those are working on it. So now I'm mainly working on laboratory experiments for aerosol particles. So now my group has been trying to develop new instruments to investigate chemical reactions of atmosphere, mainly focusing on the upper atmosphere, and also since acidity of aerosol particles is an important topic, but it has not been very well investigated. We are trying to do that. For this part, if you are interested, we can talk later in more detail, independently. So this is the basic content for today's talk. So basically, I published a review paper on haze this year. So it's an overview of it. And this paper covers the histories and controlling factors of haze, especially focusing on the meteorological factors. And then there are some descriptions about emissions and gas and particle phase species of haze. And also since I'm an atmospheric chemist, there are some discussion about what we know about the chemical reactions of haze. And then there are the reason why we have to concern about the haze so much is that it influences our health. So there is a summary on how much we know and what really needs to be done so that we can understand the impact of the haze in more detail. I guess I prepared a little bit too much content. So for some slides, I may skip. Okay, so let's start from the brief history of peatland fire haze. So many of you know that during the last glacial maximum, this area was a big land, Sunda land. But after the ice sheet melts and sea level has risen, this Sunda land had been under the water, started to be under the water. And then since because of that, now we have the Malay Peninsula and Sumatra Island or Kalimantan Island. But since this area had been a very flat region, the coastal areas of these areas, for example, the eastern coast of Sumatra or southern coast of Kalimantan Island are very flat. And then after all the ice melts, some vegetation started to grow at these coastal islands, coastal areas. Then what will happen? So when these plants grow at the coastal areas, and then once these plants die, they are going to be under the water. But since these areas are shallow water, and the flow of water is very slow, so there are not too much oxygens. So the bacteriums cannot use oxygen to digest these dead plants. So anaerobic respiration happens. And then as a result, heat forms. So as a result, these areas has been covered by peat swamp forest. And this is the one example of peat swamp forest. But the problem here is that peat is dominantly made of carbon. So once it's going to be dried, it's very easy to get fires. And then like since there are a lot of peat which has been accumulating, like once it starts burning, it keeps firing until it starts raining. So like this is the current distribution of peatland. So basically, peatland develops at the coastal areas, Malay Peninsulas on eastern coast of Sumatra, and then like southern part of Kalimantan. So when did the haze starts? Like so, it seems like there are some. I didn't read this literatures by myself, but like it seems like this person found some literatures in that's like during the 15th or 16th centuries, like when like some sailors from Europe started to travel to these regions. There are already some written records that there were haze in this area, and this map. So this map about haze was published by the U.S. Navy. Like so, this map was published by summarizing the data which had been observed from the late 19th centuries to the beginning of the 20th centuries. And then, like if you see this area, we can see that there's a haze. So most likely, like the wildfire haze has been happening in these regions, at least for the time scale of a few hundred years. And like if we focus on the like time period for the last 70, 80 years, we have a better data, visibility data. So when we go to the aircraft, like we can see that the at all the airports, visibility is always measured because it is very important for pilots. So like in the case of Singapore, like there is a visibility data since 1949. Like and then like I convert the visibilities to the extinction coefficient of light. But basically, like when this value is high, it means that there's a haze. And we can see that like there are some events in 1953 or 1954. And then after that, there was something in 1961 or 1963. And then after 1980s, 1982, 1991, and then in 1994 and 1997, there are big ones. And then like there was a short time period of very intense haze in 2013. And then like many of you may remember what has happened in 2015. So this data clearly show that haze is an important problem now, but this is not a very new problem. It has been existing since like at least for a few hundred years. But for these events for 1953 and 1954, based on the timing which it happened, I personally think that most likely it's wildfire haze or peatland fires, but I couldn't find any supporting documents to show that, like supporting documents. And like for the one in 1963, like there are some written records in Straits Times. Like so, like they also did not clearly show. I read these articles, but these articles did not clearly mention that it was induced by peatland fires or forest fires. Like, but since like that timing which that forest fire had happened overlaps with the timing which we experience haze now, I personally think that most likely that was induced by fires. But like at that time, basically there's no scientific research about this haze, so I couldn't find any scientific papers on it. Like it's not very surprising because 1960s was still the time period when scientists in developed countries started to develop the research area of atmospheric chemistry. So like even for like other countries, it's very difficult to find some written record on it during this time period.
Recording in progress.
And in 1980s to 1995, it started to have some scientific records, although it's not too much. So probably this one may be one of the first one of the earliest paper about which mentions about the forest fire haze or wildfire haze in Southeast Asia. So this is a satellite observation paper, which was published in 1989, and the data was from 1983. So at that time, some satellites started to be available to observe haze from the space. Then they identified some smokes around here. Probably, and that may be the first record. And then this paper, which was published in 1997, this paper tried to review the haze in Singapore in 1994. So it seems like this author was working, but actually working at geography of NTU. So probably this may be the first paper which tried to provide an overview about the wildfire haze in Southeast Asia. But these papers were not that I have to say, not that deep. So I don't think this author was really a person who has been working on air quality or atmospheric chemistry. And this paper was published as a part of paper to demonstrate how a satellite how useful a satellite is to detect fires and haze. So at that time, scientific research started, but it was not so intense. It's rarely changed for the event in the 1997. So why did the intense event in 1997 happen? It was partially because of the climate factors, meteorological factors such as El Nino, but it was also influenced by human activities. So in the middle of the 1990s, Indonesia started to have the mega rice project in central Kalimantan here. So that project was to drain big peatland in these areas and then convert the peatland to be a rice farm. But later, after draining, after making this kind of canal system, and after draining all the water, people find that this area is not very suitable to grow rice. So basically, after draining all the waters, the land has been abandoned. Then what will happen? We have a lot of dry peat. Then once fire happens accidentally, it keeps burning. Then as a result, the big event in 1997 had happened. So this figure shows the carbon emissions from wildfires in Southeast Asia in for the last 25 years or so. And we can see that the event in 1997 was the biggest. And actually, so far, 1997, the fire in 1997 should have been the biggest. And I personally remember that. So at the time, I was a high school student, and I personally remember that I watched the TV news about this haze, and then I remember that I still remember that there were some videos that fire was happening and people are trying to deal with that in Indonesia. At that time, I was just a high school student, and I was not very interested in this. I even didn't know that this kind of research area exists, but now, and I really didn't imagine that I am going to work on it. But eventually, I started to work on it. And then, in addition to the mega rice projects, after 2000, another thing had happened. It was the development of oil palm plantations. So this figure summarizes the production of oil palm. So you can see that after the 1990s, the production of oil, palm oil, has been exponentially increasing. And palm oil is the most important oil in the world. And among them, 84% of palm oil in the world is produced in Indonesia and Malaysia. But where do they produce it? Like now they are trying to do it in Peatland. But to produce palm oil or try to grow an oil palm over peatland, first we have to drain water. Like palm oil, oil palm cannot be grown on a swamp. But like once we try to drain all the waters, like we have the dry peat layers on the surface. So once we have the dry peat layers, and then like once fire accidentally starts, like we have the haze. Like so, all the previous events in the last 20 years or so, like the event in 2006, 2013, 2015, or 2019 were developed by these reasons. So I guess like many of you remember that there's a very intense event in 2015. And then like recently, like I heard that like there's a big event in 2023. So like I guess we should know that like the haze in these areas, it's not a very new problem. This is the problem which has been existing for centuries. Like, but the interaction between human activities and haze has been complex, and especially in the last 30 years or so, like development of the peatland for the agriculture has been a very big impact on the occurrence of the peatland fire haze. And then like when does the haze happens? So like even if the peatland had been developed, it is not like we have haze all the time. Like so, for example, even if there's a big haze in the last year, we don't have a haze this year too much, right? So like there are some relationships between the meteorological factors and the occurrence of haze. Like so, the time scale run years. Like we have ENSOR, Indian Ocean Dipole, and El Niño Modoki, or Central Pacific anomalies. Like so, these phenomena influence the occurrence of haze. And then, like for the seasonal scale, we have the monsoon. And then for the sub-seasonal scales, like we have the Madden-Julian oscillations, MJOs. Like so, among these factors, like the importance of ENSOR on haze had already been discussed in 1980s. Like so, the importance of ENSOR had been very well recognized. And for the importance of the monsoon, it was also documented in 1990s. So this one was also relatively well known. Like, but for other phenomena such as like MJO or Indian Ocean dipoles and El Niño Modoki, the impact of these phenomena has not been very well recognized or very well understood 10 years ago. But I think like we know it. We are we started to understand it better. So I'm going to talk about it a little bit. So like when the when El Niño happens, like we basically have like dry season this year and dry year in these regions because the air tends to warm up at the Eastern Pacific and then goes down in these areas. And like for the basically for Indian Ocean dipoles and Central Pacific anomalies or El Niño Modoki, they have a very similar impacts. But like it's not like when we have a very intense Indian Ocean dipole, we always have a haze. So like the relationship between the Indian Ocean dipoles or El Niño Modokis and wildfire haze has not been very well known. But I think like this paper, which was published in 2018, provides a very clear ideas. So this paper showed that when there are Central Pacific anomalies, and then Indian Ocean dipole, and then when they are increased, and then if the air converges together above the Southeast Asia, then there is a very strong downwind, and we don't have too much rain in these areas. So during these time periods, like we don't have we have haze. But if not, like if they are not in phase, then the air try to circulate like this, rather than like this. So it's not very dry, and because of these reasons, like during the out phase periods, we don't have a very too much haze. And then for the monsoon cycles, like I guess like for people who have been here for more than 10 years, like I guess people started to realize that we have haze mainly in September to October. Like it is because in these regions, especially southern part of Kalimantan or southern part of Sumatra, like those are like major source of areas for wildfires. They experience like dry seasons in these periods. Then like the fire hotspots increases during these seasons. Like but there are some exceptions. For example, like in the case of like 2013, like there was a case in June. Like it has happened in Central Sumatra or like a rare province. It is because in those areas there is a dry season in June. So like actually the fires in Central Sumatra is not as intensive as the ones in southern Kalimantan or southern Sumatra. But since like Central Sumatra is closer to the areas where people are living, like Kuala Lumpur or Singapore, in terms of the impacts on human health, like it's actually very important. And then like for the like subsidiary variations, like the role of potential role of Madden-During oscillations has also been discussed, but it is not very clear. But I guess I like in this paper like I could demonstrate it. So the Madden-During oscillation is the like basically the move of the rain or convection system like over the equators from the Indian Ocean to the Central Pacific. So in the phase 2, like it's over the rain is at Indian Ocean. For phase 3, it's over Southeast Asia, and then for phase 4, like it's the western part of the Southeast Asia, and then for phase 5, it goes to the Pacific Oceans, and then for to go to the phase 6 or 7, it moves to the center of the Pacific Oceans. So during the phase 2, 3, 4, since we have a lot of rain in these areas, the air quality of this area tends to be like better. Like so, since we have a lot of rain, like we have less haze. So like for the time scales over the like sub-seasonal variations and like seasonal variations and annual variations of haze. I think like compared with 10 years ago, we started to understand it better. Like, but still, the accurate prediction of MJO or ENSO is not an easy job. So I think like to like make the occurrence of the haze to be predictive, we still have to work on. And then like how much then the next question is what would be emitted from the haze and how much would be emitted. So the most important thing is the carbon emissions. Like when fire happens, most of the chemical species are converted to CO2. So trying to estimate the CO2 emission is the most important thing. And to do that, there are like both bottom-up approach and top-down approach. So bottom-up approach is basically the way that we try to estimate the burnt areas. And then from the burnt areas, we try to estimate how much carbon has been emitted. Like, but this is not very easy for peatland fires because we don't know, or it's very difficult to tell how much peat has really burnt. Even if fire happens, it's not like all the peat of that area is going to be burned. Like, and we don't know like if peat burnt, 10 centimeters of peat burnt or 30 centimeters of the peat has burnt. So it's very challenging. And for the top-down approach, is like we try to measure the CO2 like by the satellite or aircraft, and then try to do the inverse modeling for estimating the total emissions. That approach didn't exist before, like because the previously there was no satellite, but GOSAT or CO2. These satellites to measure CO2 started to appear after 2009. So for the haze event in 2015, these techniques were applied. So for the haze event in 1997, like the estimated range of carbon emission was 0.7 to 2.57 gigatons carbon. So there's a very big uncertainties. And like here, I compare this range with the annual emissions of carbons from major countries. Like we can tell that that's a lot, but we also have to say that the variation is very big. But like in 2015, like because of the development of both the bottom-up approach and top-down approaches, like the uncertainty or like variation among researchers have significantly reduced. And then like we can constrain, people could constrain that the carbon emission must have been around this range. So like research in the last 20 to 30 years really improved for estimating the carbon emissions. But then how can we estimate the other emission of other chemical species? CO2 is an important chemical species, but CO2 itself doesn't do too much bad things to human beings for the atmospheric concentration range. Other chemical species do bad things. So to estimate the emission of these chemical species, we use the emission factors. It's like, let's say, when 1 kilogram of fuel is burned, how much amount of PM 2.5 or carbon monoxide or methane are emitted. That is the emission inventory. But for this paper, which was published in 2010, there was no data. So at that time, since there were also no data, for peat fires, there's a caption, and then it mentions that other species based on deforestation fires. So basically, people were using a number which has no base. Since there were no data, and then people working on modeling try to use those numbers, and then many people find that we tend to underestimate PM 2.5 concentrations by a factor of few. So there's a problem. And then some people try to do the laboratory experiments to understand it. And my group also tried to estimate it by analyzing observation data. So we try to get the atmospheric observation data from this city in Indonesia, Pekanbaru. So this is a good city to investigate haze because this area is a peatland and it burns. So here, the people in the city of Pekanbaru was very collaborative. So they have been operating on these instruments to get air quality data. And then they kindly shared the data with us. And then we tried to analyze the data. And then we found that during the haze period, probably the PM10 emissions from peatland fires were 3 to 4 times higher than that had been estimated by emission inventories. So basically we could demonstrate that the underestimation of the PM concentration by models should have been induced by the underestimation of emissions. And for other chemical species, such as volatile organic compounds, people didn't know too much about the emissions before 2015. But in 2015, some researchers in US and Europe brought in these instruments to Kalimantan. So basically this is an instrument, and this is an FTIR. So this is an instrument to measure the concentrations of gas species in the air. So by using this instrument at the fire regions, like people could constrain the emission of gas species well. So like because of this research, although these numbers were not clear, like around at the point of 2010, I think like we can reasonably be confidently tell about these numbers now. Then like how does it influence the air qualities? So this paper was about the paper, and this paper was about the haze in 2015. Like so, since like people can measure carbon monoxide from satellites now, like by using the satellites, we can tell where carbon monoxide has been transported. So like we can see that the carbon monoxide concentration in 2015 has been high, like for the haze season of October, for the whole part of these areas. So it means that like the haze influence the whole part of the northern Indian Oceans to the like Western Pacific. So it's not only for the like regional problem, but it's also for like probably one third of the exterior regions. And like something similar has been also found to be ozone. So the ozone itself is not produced by haze, but the haze of forest fires like emits nitrogen oxides and VOCs. And the chemical reactions of these species increases ozone concentrations. So for the haze event in the 1997, like the ozone concentrations over the whole part of this area has increased. And then the distribution of aerosol particles were also same. Like, but then the question is, what kind of chemical species are in these aerosol particles? So the aerosol particles are the complex mixture of many things. So like we cannot tell so unless like we know the chemical compositions, it's very difficult to tell like how bad they are. Like so before our research in 2015, probably there was only a limited amount of data on that. Like so we try to do the like observation here, like and then like using the aerosol mass spectrometers. And then like so this figure is like too technical and complicated. So I may not like try to explain it in detail. Like but like basically what we find by this observation was that approximately half of like aerosol particles in haze was not the particles. Those are directly produced by combustion process. Like so, most likely these chemical species are chemical species. Those are those which have experienced atmospheric and chemical reactions, such as like gas phase reactions or particle phase reactions. The problem was that like based on this data, we could tell that some kind of chemical reactions must have happened, but we couldn't tell what kind of chemical reactions have happened. So that's going to be the topic which will need to be investigated in the future. And then for the, let's move on to the health impacts. Like, so I guess the health, impact of the health would be something which people really care about the haze. Like, so in this paper, which is published in 2021, it's try to like correlate the, like, these expressions, acute respiratory illness and Pekanbaru in like Liaopos. So Liaopos is the like newspaper at Liaopos province in Indonesia. And then like so this is the number of appearance of these like words. And then this is for the like basically the fire intensity. So we can see that like when roughly speaking, when there's a big fire, people tend to care more about haze or health. And like as far as I know, the first evidence that haze influences human health has been discovered in 1997. So like this is the PM10 concentration in Malaysia, and then like this like a red line corresponds to the like total respiratory visit in Kuala Lumpur. So once the air quality becomes bad, the number of patients started to increase. So it's a clear indication that it influenced human health. And then like it also like influenced the like Singapore. And like also like in the case of Indonesia, it is not very easy to get a very good high quality data for human health. But this paper tried to use the in 2000 Indonesian census data to estimate the like impact of the haze on human health, and then like they found that like there might like some like deaths might have been induced by haze, and like then like but like even if there are some data in Kuala Lumpur or Singapore or some census data for like Indonesia, like we don't know the number, right? So to estimate the number of, to estimate the impact of the haze on human health accurately, like we have to use a model. And then like this paper, which was published in 2013, might have been the first one. And then like and this paper like try to mention that both PM2.5 and ozone are important for human for like estimating the like human health impact by haze. But at the same time, like there are some problems. And in this paper, the authors honestly acknowledge the problems. The one problem was that the they are models, but they couldn't compare the model's results with the atmospheric observation data so that the model output is right. Like, so that part was missing. And then another thing was that the epidemiological data was missing. Like, so, like to estimate the impact of air quality on human health, we need some what we call as exposure like response functions. That function is like, let's say, if I'm going to be exposed to 100 microgram per cubic meter of PM2.5 concentration for like 10 or 30 years, like I may die like 5 years earlier than it's supposed to be, something like this. But that kind of function has already been well established in in developed countries. But this kind of function has not been developed for Southeast Asia. And like there are many factors that influence these functions: lifestyle, access to hospitals, and the types of aerosol particles, or so on. So like without knowing that, it's very difficult to estimate the impact of human health. But like for the haze event in 2015, like people still try to do it. And at that time, like we were accessible to the like air quality data in Southeast Asia. So like the issue of like answer to this about the model predictions for PM concentrations or ozone concentrations had significantly reduced. But still the exposure response functions, that part has not been improved at all. Like, so for the haze event in 2015, like this paper estimated that like approximately 100,000 people might have died because of that. But this paper like experienced like said that it should be 10% of it. That's a very big difference. And like I was actually a co-author of this one, and I also know the author of this paper well. And then like so when we discussed like it was very clear that the influence was the difference was caused by the because the exposure response functions they used were very different. So this is the very important thing to investigate in the future. Like, so then like I try to like summarize like what kind of research will need to be done in the future, but I think it's already time, so I'm going to skip this part. Like then but basically I think that it's important for atmospheric scientists and other scientists in other areas, especially social science and engineers to solve the problems. And I have been working on atmospheric chemistry, but what people working on atmospheric chemistry can do is to understand the problem which has happened. But people working on atmospheric chemistry typically do not have a capability to solve the problem. So to understand for solving the problems and to understand the problem better, I think interdisciplinary approach is going to be needed. Okay, so that's all for my talk. And before concluding my talk, I'd like to thank the Singapore government, such as NRF and NTU, for giving me a chance to do this research. And also, I'd like to acknowledge my group members and collaborators. Thank you very much.
Thank you for external. Thank you. So, since 2015, we've not experienced any severe haze events. Do you think that is because of successful government policy in Indonesia? And if so, going forward, will we expect the situation to not be too bad? Or do you think it's just the stochastic process depending on the weather, and we could experience a severe haze events sometime in the coming years?
I guess Janice would be a better person to answer this question. But my opinion is that the two very important events, 1997 and 2015, they were associated with very intense El Nino periods. And if that happens again, I think something similar may also happen again. How do you think?
Yeah, I agree. I think you are finished now. I think the main issue is just that there hasn't been very clear climate episodes. There's also been quite a lot of effort from aviation government to ban burning at a small scale level. Then, as churning phase increase, these things still happen. So it can't be a guarantee for success, but it's been a good track.
Yeah, I also have the same opinion.
I can add on some of the information on this. I think we also find the better knowledge about the development make the situation better. Because last year we also come across the Nile episode, but the problem is it was not so big because we gave the early warning to the government, and then they had discussion between the government in the region how we tackle that kind of potential risk in the region. So at the end, we saw that the evolution of the hotspot. Once we find the episode, that hotspot decreased very dramatically. So that should be some of the very good effort in the Indonesia to control the source, even though we have a favorable climate condition. That we measure by our LiDAR already, the whole mechanism dropped within 2 days. This is amazing. Even though the climate condition is a very, very good for generating the effort, but it happened for a short time, not like 2015 that lasts for months. Right? So this is, I can say, this is what I saw. It's kind of the episode government, I believe. And other questions?
Thanks very much, Mikinori. I'm just curious to mention that one of the